on page 3 in your notes, and we will be talking about the second type of division that we can do with polynomials. So yesterday, we did talk about division distribution. This is only when you are dividing by a monomial. So 3xy, one chunk. 2xy, y squared, z cubed, one chunk. But over here, I am dividing by x minus 3. And this shows I am dividing by x plus 4. These are both binomials. And when I have a binomial or a two-chunk term, then we have to use either long division or synthetic division. So folks, our focus for today is going to be long division. We won't start synthetic division until tomorrow. The first thing that I want you to write up at the top of this page is check for power placeholders. And this is going to be your first step for both long division and for synthetic division. So checking for the power placeholders is kind of like having zeros in for digits, where we need to make sure every digit is covered. We need to make sure every part of the polynomial is covered. At the end, your answer will be written in the form quotient plus the remainder over the divisor. So we are going to write our answer in this form. And if you have a highlighter or something to circle with, a lot of times students will forget the plus sign. So quotient plus the remainder over the divisor. Now, before we get ahead of ourselves here, if you're looking at that going, ooh, that's a lot of vocab I haven't seen in a while, let's just look at the basic setup for a division problem using the little long division box. So does anyone remember what we call the thing that goes inside the dividing house? The dividend. So the dividend is what goes in the dividing house. Back in middle school, they said that the dividend is the biggest item that goes in the dividing house. But for us, since the polynomials can be the same size, I want you to put that the first item always goes in the dividing house. The number on the outside of the dividing house to the left is called the divisor, the thing doing the dividing. The answer that we get on the top of the dividing house is the quotient, which is our vocab word that describes the answer for a division problem. And then I'm going along, and then I get something down here called the remainder. That is what is left over after we do our dividing. And as we will see, our remainder is an important part of our final answer. So this is our vocab. So dividend in the dividing house. First thing, divisor, what's doing the dividing? Quotient is what goes on the dividing house, and the remainder is what is left after we carry out our division. Let's go ahead and just do a regular division problem. So 133 divided by 2. So 133 divided by 2. 133 is our dividend. 2 is the divisor. Now, back in middle school, you may remember saying 2 goes into 1 how many times, right? Right. And what would we say? 2 goes into 1 how many times? 0. So we move to our next digit. But instead of saying 2 goes into 13 how many times, we're going to practice using our polynomial thought process. We're going to say 2 times what on the dividing house gets me really, really close to 13. 2 times what gets me closest to 13? 6. So 6. So 7 would be too much. That would give us 14. 6 is what's going to give us something less than or equal to that. Then what do? Make Mrs. Mendenhall proud. We're very proud from her. After we choose what goes on the dividing house, we multiply these to get our first line. So 2 times 6 is 12. Anyone remember what we do next? Subtract. Now, we don't have to do this with regular long division, but the parentheses are going to be a big part for our polynomials. So trap in parentheses and subtract. And then we get 1. Then what do? Bring down the 3. You guys are awesome. So that is one iteration or one cycle of the long division process. Now we repeat the process. So that's not the answer yet because we just brought down this digit. Now I can say 2 times what gets me close to 13? 6 again. So then 6 times 2 is 12. Enclose in parentheses and subtract. And we get 1. 1 is what we call the remainder. Now, back in middle school, a lot of times they'd have you say 66 R1. Do you remember that? And it's like, all right, but we have this floating R1. Is that really numeric?
Yes.
It just describes what's left over, but if I want to get a solid answer, we are going to use this format. So instead of using the mysterious R1, how we write this as a full number is 66 plus the remainder, which is 1, over the divisor, which is 2. So we would get 66 1/2. Folks, let's go ahead and check this on our calculator. If I do 133 divided by 2, we see that we indeed get 66.5. So writing it in this format as plus the remainder over the divisor, I don't just say, hey, that's what's left over. This gives me my exact numeric answer for the division. So this is the process we will be using for polynomial division, and this is the format that we will be using to express our answer. Quotient plus the remainder over the divisor. Any questions so far? All right, so let's go ahead and do our first setup. My recommendation is you leave like a finger's worth of space above your dividing house for your quotient. So who's going to go in the dividing house? Who's our dividend? The first one. So I'm going to do x squared plus 3x minus 40. And then x minus 3 is the divisor. Let's talk about checking for power placeholders. Power placeholders means every power, starting with the degree down to the constant, needs to be covered both in our dividend and our divisor. So if I look at my powers, I go from a power of 2 to a power of 1 to the constant. Everybody's covered. There are no powers being left out. In our binomial, we go from a power of 1 to a constant. That's all good too. So just put a note, no placeholders necessary. All of our powers are covered. So what's different about this than the long division problems we were just doing? Well, instead of dividing by one term, we are dividing by 2 terms. What I would do is draw a box around your variable term. This is going to be your leader. Whereas the -3 will be the tag-along term. The leader does all the deciding, what goes on the dividing house and what we choose to multiply by. The tag-along term, it just comes along for the ride. So when I decide what goes on the dividing house, we are only going to be looking at the leader term. So I'm going to cover up the tag-along term. And I'm actually going to cover up everything but the first term in the polynomial. So I'm comparing this leader term with that leader term. And the question we want to ask is, x times what on the dividing house will give me x squared? X. So x times x will give me x squared. So the leader term decides what goes on the dividing house, and then we are going to multiply by both parts of the divisor for our first line. So this -3, it tags along. It doesn't help with the deciding of this, but it comes along for the ride on our first line. So x squared minus 3x. Enclose in parentheses and subtract both of them. So what we are going to do here is take x squared minus x squared, which is 0. And that's our goal. We always want to have an exact match with that first term. But now I also have to subtract this second term. So what's 3x minus a -3x? It's 6x. So this negative combines with this one and turns into a big old plus sign, and I get 3x plus 3x, which gives us 6x. That's usually the part where students go wrong with this, is distributing the negative. Now here's my warning. Sometimes students like to actually distribute it in. This turns into a giant mess when you are trying to check your work. So I actually recommend leaving the negative on the outside and actually reading it in a zigzag pattern so that you are reading the minus sign with it. So we subtract the negative, it turns into a positive 6x. What's your gut telling you we should do next? I bet you're right. Bring down that -40.
Yeah.
And that is one iteration of long division. And now we repeat the process. We cover up the tag-along term. We cover up everything but that leading part of this guy. And we say x times what on the dividing house will give me 6x. Just 6. So x times 6 gives me 6x. So plus 6 on the house. Now, we have chosen that term that goes on the house, but now I have to multiply it by both the leader and the tag-along term for my next line. So 6 times x, 6x. 6 times -3, -18. Enclose in parentheses and subtract both. So 6x minus 6x is 0. What about -40 minus a negative or plus 18? -22. Am I done?
Nah.
I'm done doing iterations because there's nothing else to bring down. And if I tried to continue, x times what is -22? Is there any way for me to get rid of that x? No. So once we get the final term and there's nothing else to bring on down, we don't have to keep adding decimals and digits afterwards like we do with regular long division. That is my remainder. So now we are going to write our answer to this problem as the quotient, which is x plus 6, what I got from doing the division, and then plus the remainder, -22, over our divisor, x minus 3. Making sure we include that plus sign, connecting those two. Because when we divide a polynomial by a polynomial, we should get another polynomial with everything joined by pluses or minuses.
Can we check ourselves?
You know, I'm glad you asked that. Let's see, what time are we out of here for lunch?
5 minutes.
So, you know what? Since you asked, I'm going to show you how we would do the check for this. Let me grab some scratch paper. So, folks, how do I check division? What's the opposite of dividing? Multiplying. So, if I have 20 divided by 4 is 5, we get 20, we subtract, and we get 0. How would I check to make sure 20 divided by 4 is 5? We would multiply those two together. So 4 times 5 should be equal to 20, or the divisor times the quotient should be equal to the dividend. So how are we going to check ourselves on this one?
X minus 3 times X.
We're going to take x minus 3, the divisor, times our quotient, but we also have to include that remainder over the divisor. So this is my full answer. And what should this be equal to?
The A.
X squared plus 3x minus 40. So it looks awful, but here's what we're going to do. I'm going to distribute this to this. Distribute this to this. And distribute that to that. Actually, might be easier to do it the other way. No, we'll go ahead and do it this way. Okay, so we're going to take x times x, x squared. X times 6, 6x. X times that business, that business. We're going to put the x up with the 22. Does everyone see what we did there? Yeah. So now, negative 3 times x, negative 3x, negative 3 times 6, negative 18, and then negative 3 times 22, that's 66, over x minus 3. Are we a little bit nervous?
Yeah.
Why are we a little bit nervous? Because we've got those fractions involved. So let's just see what happens here when we start combining our like terms. We've got x squared. We've got 3x. We've got that minus 18. Now, these two fractions have a common denominator, x minus 3. So I'm going to leave the denominator and add the tops together. Did we get the same thing we should be getting yet?
No.
Not yet. We can actually simplify this fraction. This is kind of a nice lead into what we're going to be doing in one of our next units. So, do I have a GCF I can take out of the top?
Yeah.
What can we take out of both of those? We can take a negative 22 out, which leaves me with this. Then, we can cancel out the x minus 3's. And x squared plus 3x, negative 18 minus 22. Boom! Goes the dynamite. You zoom out.
I'm gonna check every single problem.
And we did get what we were supposed to get. Do I expect you to check it this way?
Yes.
No, absolutely not. But if you really wanted to, you can to check division. The opposite is multiplication. So if you want, you could check your work that way. All right, folks, we're going to go ahead and jump to problem B. Well, actually, before we do problem B, any big questions so far? Remembering to subtract all the terms is tricky. The other thing is students get stuck with doing the green lines. Folks, there's a reason why I switch colors for every line so that I keep track of what did I actually bring down and what did I put on here to multiply. If switching colors helps you, I strongly recommend that you do it, but it's really easy to just get lost and say, wait, where did those numbers come from? What was I doing? Was this what I multiplied or was this what I brought down from the previous step? So folks, we're just gonna jump right into the setup of this next problem. And we're gonna check for power placeholders first. So as I look at the dividend, the first guy, this stuff divided by that, my power goes from 3 to 1 to the constant. Are we missing something? Which power are we missing? We're missing the power of 2. So I'm going to put 0x squared in as a placeholder. What's 0 times x squared? 0. So am I changing the value of anything? Nope, we're just adding 0 to it. And if you're like, seems dumb, why are we doing it if it's not changing the value of anything? It's because this is going to help us when we are doing our subtraction. Then we go from 1 to a constant. No placeholders necessary on the bottom. I've got the highest power down to the constant. Yes?
What's a placeholder mean?
So placeholder, kind of like a digit holder, like when you put 0 in for like the middle digit of a number.
Why though?
We're going to see why. So take me for my word on it. Once we start doing this problem, you'll see why we need the placeholder. Just kidding. Cliffhanger. After lunch. Goodbye.
Should I walk to lunch?